Alright, and for my last video of the night, I'm going to show you guys a little bit about inheritance, and this is going to be kind of a rush together video that I hope that I can get done soon. So one of the major shortcomings of using classes is when we build a method. So let's say I have a method over here that takes a test class. So let's say public static void testing except in a test class that we call test. Now my question is, what if I have another class called test class 2 that has a very similar type of structure? And as you can see, I mean, this is something that's pertinent to me because in the program that I'm making, I have, a variety of different handlers, and they all have the same basic, structure. So as a result, I need something better than implementing a class and having to have constructors that, I have 10 of the same method, one for test class and another one for like a test class 2 or a test class 2 like that. It doesn't work. It's not sustainable. So as a result, what we can do is we can make what's called a parent class, or in this case it's going to be an abstract class that's going to kind of act as a framework for all of our other classes. So let's make another one, and we'll just call it a parent class. And we'll get rid of that and that star because it bothers me. I haven't reformatted my stuff on this computer yet, so you guys will have to bear with my kind of neurotic tendency there. But in this case, you see how we have a public class? We don't want it to be public because public has to abide by certain rules. We're going to make this abstract. And abstract means that it's a framework and it can't be implemented anywhere. So that means if I want to make a class parent class, like remember how we made this test class object, you can't do it. So right now if I type parent class parent equals new parent class, it won't let me do it. It's abstract. It can't be initialized. So as a result, what is this good for? Well, let's say I say this, implements runnable. And then in here, let's say I take all the stuff that was in here, right? And I just copy paste it over. Just like this. Yeah, we can probably get rid of that. So we can call this, we can make a constructor for this and say public parent class and make it accept those few things. And yeah, let's just keep it like that. That's beautiful. So test class is going to, instead of implements runnable, it's going to extend or extends parent class and I will have to kill off that constructor because you can't construct that anyways. So then let's say that we just have one unique type of thing in here, and let's just call it a int or public int polynomial, because why not? Okay, so now what we can do is, oh, and I suppose I could have tossed the constructor over here. So let's say public oh my god, public test class. Sorry, just had a mind freeze there. Public test class, and it's going to take in, what did we have over here? An int, double, and another int. So int, comma, double. And so then we're going to toss that like this, and we're going to say int, or this dot polynomial equals, we're going to call that just A and B and C, because I'm very lazy right now. So this dot polynomial equals A, this dot price equals, did I make price the double? Yeah, okay. So that's going to equal C, and to just keep these in order, this dot quantity equals B. So now when I go to make this constructor, I need three things. So let's make it a 3 and another comma. Illegal start of expression. Let's try saving. Why is that an illegal start of expression? Test class test equals new test class. Oh, that would do it. Okay, so now when I give this a run, you'll notice that it still works the same way that it used to. In this case, it does look like I've butchered something along the way. 1, 3, and 2.5. Looks like the 1 for polynomial is not being output because I never told it to. This dot polynomial. Oh, and as a matter of fact, since that's not in the parent class, I can't have it output polynomial with that function. So that's kind of the distinction here, is if you're only using something specific for this one class, you can't call it with the parent class. So in this case, since the runnable is inside of our parent class and not our child class, we're not able to add that output to our runnable. But let me show you kind of the advantage to doing something like this. Remember how I said, I can have, something like this where I'm taking in a test class. Well, what happens if I make another test class file and call it a test class 2? And I'm just going to very quickly populate this with what's in test class. And so we're just going to copy paste the whole thing, test class 2, and it's going to be the same idea, except for this one's going to be quadrangle. And so again, this dot quadrangle is ABC. So now we're just going to copy paste the same thing. So test class 2 equals new test class 2 and test 2, test 2. Okay, so as you can see, we've now made two classes. Now let's say if we wanted to add to the values in them, because we do have similar classes of quantity and price. So let's call this adding. So we could still make it so we accept, two different classes, and we could put in a comma here and say, test class 2. Test 2, and we could go from there. But again, you saw this file, I have 12 projects, and each one of those is containing, its own specialized handler for that one project. But they all fall under one major object. So as a result, in this case, we're going to take in a parent class. And we're going to take in a parent class, and we're just going to call it object, or obj. So in this case, what we're going to do is we're going to take in obj, and we're going to set dot price equal to 10. And obj dot quantity equal to 15. So let's do this a little differently now, and we're going to, let's just make it so we only send test into that. So we're going to say adding test. And it's void. However, these are passed, they don't pass a reference because there is no pass by reference, but they do pass a copy of the object that later overwrites the object, which is really confusing compared to C++'s pass by reference. But anyways, you'll see that I gave it a run. It accepted that value just fine, despite it not being a parent class. This is a test class, and so at no point have I actually, put a test class in here. But since it extended its parent class, we're able to treat it that way. So what does this mean? This means that we can make methods and handlers for methods that take in an object of any type and handle them in a certain way. And so this is very important because this gives us the ability to create, multi-tiered class structures that allow us to better utilize a wide variety of shared functionality without having to have complex constructors, without having to switch based off of, what kind of object we're using, or not having to have, in this project's case, 15 different constructors, because ew, that's gross. Who wants to code for that? But in any case, hopefully this has been a decent introduction to how you're going to be handling uh, you know, simple inheritance. There is more complicated inheritance than this, but I think that this is about as complicated as we're going to need to get. Um, I don't think that we're going to cover inheritance in too much more detail than this. However, in future lessons, I am going to assume that you have a grasp on this, because we are going to be moving on past that. So with that being said, I'm going to wrap this up here. I hope that you guys have enjoyed this, and I'm going to toss this on IDE1 and the video on YouTube. If you have questions, let me know. Thank you.